I quite like and usually recommend the page I fucking love science, both to my friends and students. I fucking love the name, especially in the classroom. But I also very often disagree with its uncritical admiration and promotion of what I call a green agenda. Please don't get me wrong. I think that we humans should treat the nature with respect and dignity and try to pollute the environment as little as possible. And we also have to think about new technologies and consider changes in our behavior towards the nature to allow us saving the planet for the next generations to come. Maybe not in the perfect shape, but at least in quite good condition. But that does not mean to be stupid! For example, some time ago there appeared a startup project called Solar Roadways, or as it's also called, Solar Freakin Roadways! An idea to replace common blacktop asphalt roads in the whole USA with smart photovoltaic glass panels to produce electricity and containing LEDs to draw images. I don't want to spend any more time with that stupidity. Please see the links below the video, and more importantly, see the videos where Thunderfoot eviscerates the idea from financial and technological point of view and breaks it into tiny pieces of multicolored glass and LEDs. Well done, Thunderfoot, well done. But these stupid ideas are unfortunately not exclusive to the America. Let's look to the Europe and see the wind freaking trees. Okay, so what the hell is a wind tree? Or l'arbre à vent? Because it's actually a French idea. And why is it stupid? Well, the wind tree is a wind power generator in the shape of the tree. The idea behind this is simple. The existing wind turbines are monstrous columns with noisy and dangerous propeller blades, and they look quite ugly. Well, surely not for everybody and every time. For example, I personally like these when they were installed, and I really hate this or this. Well, on the other hand, this one is... I don't know, I don't hate it, but I don't find it much appealing either. But it doesn't matter. The motivation behind wind trees is not just aesthetic. According to New Wind Company, which is behind the wind trees project, the main concern seems to be transportation of electricity over great distances and unreliability. So the better way is to put the wind turbines right into the cities, next to the customers. And the wind tree is a solution. I don't want to debunk the wind-generated electricity as a whole, because I find it useful in remote locations, off-grid systems, and places and applications where expected low reliability is not an issue. But the problem with wind trees is not in the wind, but in colossal waste of resources. So let's begin. The price of one wind tree, according to company page, is 29,500 euros. Pretty steep, isn't it? And what we get for such a bargain? Installed peak power of 3.1 kilowatts. Not megawatts, kilowatts. That means 9.5 euros per 1 watt of installed power. Let's look at the other power sources at Wikipedia and let's compare. 9.5 euros is approximately $11. Coal is 2.1. Solar systems are 2.6 to 4.8 in different countries. Wind turbines around 2, gas 1. I don't see any nuclear plant, but it should not be so much different from the coal. Wind trees 11. Oh. Well, the installed power alone means nothing. So let's look at the estimated power output at different wind conditions according to company's material. The average speed at 3 meters per second, 1300, 4 meters a second, 2600, and 5 meters per second, 3100. Okay, so for brevity, let's take the best estimated value of 3160 kilowatt hours per year. That means that the average power we can use is in best case around 360 watts, so the efficiency is around 11.4%, probably less. Well, fine, now it's well known that wind is a bloody unreliable bastard. So the final price per installed watt is 9.5 divided by 0.11 equals 83.3 euros or $97.5. That means that the wind tree, in its best case, circa 50 times more expensive in installation costs than average coal plant, counting that coal plant operates on 24/7 basis. Wow, so much better! But we're not finished yet. Now we'll take a look at the energy prices and mix them to the equations. According to this page, average consumer price in 2013 in European Union was circa 25 US cents per kilowatt hour. That means 21 euro cents. If I choose grid electricity, I spend annually 0.21 times 3160 equals 675.2 euros for the same amount of energy produced by wind tree. So the wind tree must run at its full power without any break for 43 years in the European Union and around twice the time in the USA, just to pay itself. And please don't forget that this is the best case scenario. In most cases it will take much more time, even centuries. And that was just the cost of the installation. We didn't take into account the maintenance yet. Which brings us to the construction and maintenance. First, let's look at the construction. So, the wind tree is an assembly of steel frame branching up to 11 meters, 36 feet in height, divided into several steel branches to the total diameter of 8 meters or 26 feet. The frame has 72 wind turbines attached as leaves. So the tree itself is pretty big, 11 meters tall, 8 meters wide. The minimal distance between two trees should be no less than 8 meters, probably more. That is not very impressive regarding to the produced power per unit of occupied volume. Let's make some calculation. So the volume of the tree crown is 4/3 times P times R cubed equals 268 meters cubed or 9,464 cubic feet, which means that 1 cubic meter provides circa 11.6 watts of installed power, and at 11% efficiency circa 1.3 watts per cubic meter of space. And I'm not counting the volume below the generator sphere. Is it good or is it bad? We can now easily compare this case to a solar panel with similar size. First, we slightly simplify the problem. Instead of sphere, we just take the area of the circle with a radius of 4 meters. That is pi times r squared equals 3.1415 times 4 times 4 equals 50.2 square meters. Now it's quite simple. Since the solar radiation brings maximally around 1000 watts per 1 square meter, the maximal power of the solar system of given size could utilize up to 50 kilowatts of solar power. The real world value depends on the used technology, but is about 20% of this value, so let's say 10 kilowatts, 3 times more than the installed power of the wind tree. Also, no need to mention that the solar panels take much less space than a wind tree, because they are practically two-dimensional. I don't know about your town, but if there is one thing cities usually don't have, that is a vast, unused space. But the solar panels are pretty expensive. Well, yes and no. The median installation price of PV panels according to this page is between 3.9 or 5.9 USD per install watt, compared to $11 per wind tree. I am personally not a big fan of photovoltaic panels, but in this case I would choose them instead of wind trees. Solar panels might be stupid as well, especially using them massively on the rich agricultural soil. But it is now clear which idea is even more stupid. Plus, these solar panels can be easily attached on the existing surfaces, for example roofs. And they are also easier to maintain, which brings me to the maintenance. I must admit, I am not an electrical or mechanical engineer, and the brochure is not very informative about maintenance issues, so it will be not so much of calculations, but rather guesses based on the provided info. My first question is, what if one of the generators fails? Answer in the brochure. Even if one leaf breaks down, all the other will continue to flutter and therefore generate 100% per connection, which significantly increases its service factor. Well, at least I know from the piece of text that it's not connected in series, but parallel. What a relief! It would be really sad if it stopped working each time while a single part breaks. By the way, the sentence itself does not much sense and makes impression that the power output will be still the same in the case of failure, which is certainly false because each turbine contributes with approximately 1.4% of the total output. So for example, a failure of 5 units means power drop of 7%. The next question. So how and why could the turbine stop working? Answer: not in the brochure, but I guess it could be from many reasons. Since the machine is exposed to the outdoor conditions, most of them could be associated with the weather. For example, a very strong wind could easily break the propeller screws, since they seem to be attached to the generator just by some clipping mechanism or even glued together. Rain, water, snow, hailstones and ice, lightnings, well, that would be hilarious. Dust and dirt, birds and other animals, human vandals, moving pieces of bearings are generally prone to failure, and so on and so on. I don't know the cost of the generator itself, but at least I have to admit that the cost of the propeller screws, that will be probably most damaged and replaced parts of the design, might be pretty low, let's say a few euros a piece. It's just a piece of plastic anyway, could be produced in large quantities in China for a reasonable price. But a replacement itself might pose a problem. First of all, how can we know that the generator does not work at all? No, seriously, is it even possible to indicate a single unit failure from some remote central office, for example from the power output deviation, even with such unreliable power source, which might be connected with other trees to form a more powerful farm with the aggregated output? Maybe. Please, some electrical engineers, comment if you like, I'm just asking. Okay, the viable option seems to be a visual check, that someone has to go out and look at each tree on its location, if some turbine stopped working. Yes, for 1 or 2 trees, probably not a problem. For hundreds or thousands of trees, well, I would not apply for the job. Now, let's say we have identified some broken generators and want them to be replaced. It's quite tricky to guess from the provided pictures the spatial distribution of leaves inside the enveloping sphere of the tree crown, or how dense is the tree, if it's possible for somebody to climb it with a ladder, or how hard would it be to reach all the leaves even deeper inside the tree from the lifting platform. Maybe piece of cake, maybe pain in the ass. And I want to see how much effort it will cost if somebody will try to apply a new anti-corrosive coating. And for many decades it will take people and money just to run the damn thing. Well, I think I'm done. I'm just tired. I don't want any more guesses. I have my calculations already done. I don't want to think about it anymore. This project sucks. And I just wanted you to know that it also sucks very hard. For the conclusion. Well, now maybe you'll ask me, why did I spend my time with this thing? Which might be stupid just for me, but could be useful for many fans of green technologies. After all, nobody points a gun at me saying, buy 1 or 2 wind trees or I shoot you, motherfucker! Well, that's not entirely true, since the cost of the system is so stupidly high that it will take, in the best case, half of a century just to pay installation price, not counting the maintenance. No reasonable person will never ever voluntarily put his or her own personal money into it. Fine, so where is the problem? It's all over then. Nobody will buy it. Case closed. The problem is that your government or municipality could willingly and happily spend your money to buy that bullshit. Either just of simple stupidity, corruption, or just to look green enough for being proactive to save the world, need to spend money from some subsidy, relief, media pressure, or fulfill some stupid energy diversity quota. I don't know, but the number of such reasons is frighteningly high. Well, as I said before, let's be friends to the nature, let's take the actions, and leave the world a better place. But not at any cost. Behind each action should always be a good reason. I know, it's very hard to pick the best option, but at least we should not pick the wrong ones. And for those who don't mind to invest their time and money to a project lasting for decades, even centuries, instead of a wind tree, plant a normal tree. Seeds or saplings are almost free, and after years, they may bring joy and fruits even to your grandchildren.
L'arbre à vent.
L'arbre à vin.
L'arbre à vent.
L'arbre à vin.
L'arbre à vent.
L'arbre à vin. Van. Van.
No? Dobrý.
Ar. A. No. Arbe. A v. Hej, já se z toho podělám, to jsem si teda na sebe ušel zase něco, bože.